Now we are going to discuss about the impedance matrix. So we have discussed about the admittance matrix in load flow analysis, right? So what is the how the admittance matrix is defined? The current is equal to the admittance matrix into V, right? Where Y is admittance matrix. Now if you multiply by the inverse of admittance matrix, Y inverse I is equal to V you are going to get. Now how is impedance defined? Impedance is the Z matrix, which is defined as V is equal to Z into I. So if you compare these two equations, you are going to see that the impedance matrix is the inverse of the admittance matrix. Okay. Now the admittance matrix is easier to form. The impedance matrix is a little more complex. If the number of buses are small, the power system that we are taking, if it is a small power system, then we can easily find out the admittance matrix and take the inverse of admittance matrix. But if the number of buses are large, okay, so then the order of these matrices is going to be increasing and the inverse will become more difficult to find. Okay. So we need to know how to form the Z bus matrix. In order to form the Z bus matrix, you need to know how to modify the Z bus matrix. So it will become more clear to you as we discuss why this is the case. So we are going to discuss the modification of the impedance matrix first. Now the very first case, you have an existing power system here. Okay, this is existing power system network. Okay, now there is a reference, this is the ground. Okay, the ground or reference, whatever you want to call it. Now here we are going to add a new bus and a transmission line between this bus and the ground. So this you can write new bus, and this impedance that is associated with this transmission line we are taking as ZB. Okay. Say the existing power system network, it has n number of buses, right? Then this new bus will be named n plus 1, right? So Z old will be having an order n into n, and now the Z new, this is going to have Z old will be as it is. Okay, Z old, which is of the order n by n, but you have an additional row as well as column, so that this is going to become an n plus 1 into n plus 1 matrix. Okay, so what are the elements of this new row and column? Okay, so all of these elements except the diagonal element, it is going to be diagonal element, you are going to have ZB, all other elements are going to be 0. So this is the first case, we are adding a new bus and a transmission line from the new bus to the reference. Now the second case, we are going to add a transmission line from the new bus to an existing bus. Okay, so that means you have the existing power system network here. Okay, and you have the new bus. From the new bus you are going to have a transmission line. So this impedance we are taking as ZB. Here you have some bus J, while this is the new bus, right? So we are taking n buses initially. So this new bus will be of number n plus 1. Okay, so in this case what is going to happen? Z new is equal to, first Z old you will have as it is, then new row and new column you are going to have, so that the order is similar to case 1, the order is going to become n plus 1 into n plus 1, right? How many number of buses are there? That much is the order of the impedance matrix. Okay, so here we forgot to draw the ground. Okay, so now what are the elements of the new row and column? So the diagonal element, this is going to be ZJJ plus ZB. What is ZJJ? It is the element of the old matrix of jth row and jth column. Okay, so it is a diagonal element. Now why J? Because from jth bus we are connecting the new bus. So that is why ZJJ. Now the other row elements, this is going to be same as the jth row. Okay, so elements of jth row. Of the old impedance matrix, and similarly the column, you are going to have the elements of the jth column. Okay, elements of jth column. So you can write this again. Z old is going to be as it is. Now here ZJJ plus ZB, here there is no confusion. Now what are the elements of jth row? Jth row means you are going to have ZJ1, ZJ2 and so on, right? So here you are going to get ZJ1, ZJ2 and so on till it will continue till ZJN. Okay, and similarly here Z1J, Z2J and so on till ZNJ. Okay, so this will be the new matrix when we are connecting a transmission line from an existing bus to a new bus. Now the next case is we will be adding a new transmission line from the existing bus to the ground. Okay, so this is the existing power system network. Here existing bus is present, so this bus number we will take as J. Okay, and there is a new transmission line. See, there is no new bus here, only a new transmission line. So the impedance we are going to take ZB. Okay, now in this case it is going to be a little more complex. Every element is going to change. So first we are going to take a temporary matrix. So temporary matrix is pretty straightforward, there is no confusion here. Z old will be as it is and a new row and new column will be added. See, there is no new bus here, but this is a temporary matrix. Okay, so we are making use of a new row and column. So now these elements, the diagonal element is ZJJ plus ZB, just like in the case 2, right? And the other elements also, here you are going to get ZJ1, ZJ2 and so on, and here Z1J, Z2J and so on. Okay, so this is same as case 2. Okay, same as in case 2, we obtain a temporary matrix. Now what happens in the second step? This is now becoming what? N plus 1 into N plus 1. We want N by N matrix. Okay, so in the step 2 we are going to get the actual modified matrix. Now what is going to happen here is each of the elements are going to be modified as follows: ZPQ new. This is going to be ZPQ old, the old value you are going to take, minus ZPI ZIQ divided by ZII. So here what is I? Here I is nothing but N plus 1. Okay, so in order to avoid writing ZP of N plus 1, I have written ZPI. Okay, otherwise this formula will become very clumsy here, right? So I is nothing but N plus 1. So each of the elements you will use this expression to find out the new elements, and then you will delete these extra row and columns. Okay, first find this, next delete extra row and column. So we will take an example here, then it will become more clear to you, right? So this is only for the sake of example. Let n is equal to 2. That means number of existing buses is 2. Okay, and we are adding a new transmission line from the first bus. That means j is equal to 1. From first bus to the ground, we are adding a transmission line of impedance ZB, let us say. Okay, so let also the old matrix we are just going to take as Z11, Z12, Z21 and Z22. Okay, now what we are going to do, step 1, you can first find the temporary matrix. So how you are going to find this? Z11, Z12, Z21, Z22. First you are just writing down the old matrix. There is no change here. Now we need an extra row and column. Okay. Now here j is equal to 1. So the extra row will be nothing but the first row. So here you are going to get Z11, Z12. Okay. And the extra column is going to be the first column. So that is Z11, Z21. Then what will be the diagonal element? ZJJ plus ZB. Here J is 1. So Z11 plus ZB. So this is the temporary matrix. Now we will get the actual matrix. So here what each of the elements you are going to change into what? ZPQ new is equal to ZPQ old minus ZPI ZIQ by ZII. Okay. So here I is nothing but n plus 1, which is equal to 3. Okay. So we will take one element, the others you will have to do in a similar manner, right? So we will take, say, Z22. That means P is equal to 2 and Q also we are taking as 2. Okay. So Z22 new, this is going to be equal to Z22 old. Okay. Or we will take as Z2 dash, right? This will be more clear. Z2 dash is equal to Z2 old, which is nothing but Z22 minus ZP is 2, I is 3. Okay. And next I is 3, Q is 2 divided by Z33. Okay. Now what is Z22 is this element here, Z22. Z23 is this element, second row and third element, right? So Z21 is Z23 here and Z32 is third row second element, okay, which is Z12 divided by Z33 is Z11 plus ZB. Okay. So here Z23 is equal to Z21, Z32 is equal to Z12 and Z33 is equal to Z11 plus ZB. Okay. So in this manner you are going to find, similarly find Z11 dash, Z12 dash, Z21 dash, okay, Z22 dash we have found out, that's all. Okay. The other elements you are going to just ignore. Okay. Then final matrix is, required matrix is going to be Z11 dash, Z12 dash, Z21 dash and Z22 dash. Okay. So this is how you have to find out. Now the last and final case, we have adding a transmission line from an existing bus to another existing bus. Okay. So this is existing power system network, this is the reference, and here you have an existing bus J. Okay. So let us take this J and another bus which is K. Okay. Now a new transmission line is added from between these two buses and impedance we will take as ZB. Now this also, just like in the previous case, first you have to find out the temporary matrix, temporary Z matrix. So what will this be? This is going to be Z old will be as it is, there will be no change. In addition, you have to add something like this, Z1j minus Z1k. Okay, that means the jth column and the kth column we are finding the difference. Okay, and Z2j minus Z2k, so on, like that. Okay, and similarly in the rows you are going to have Zj1 minus Zk1 and so on, Zj2 minus Zk2 and so on. Okay, so these are the elements, and the diagonal element this is going to be Zjj plus Zkk minus 2Zjk plus Zb. Okay, so this will be the temporary matrix. Now in step 2 what you have to do, this is also similar to the previous case, same as previous case. What was the formula? Zpq new is equal to what? Zpq old minus Zpi Ziq divided by Zii. Okay, where I is equal to n plus 1, right? This here is Z old is n by n matrix, and we are adding a new row, n plus 1th row and n plus 1th column. So that I is n plus 1. Okay, so just like in the previous case, we have to find out each of the elements using this formula, and then finally you can even take it like step 3, right? Step 3, delete ith row and column, or you can say I is equal to n plus 1th row and column. Okay, so in this way you are going to get the Z bus matrix. So case 3 and 4, they are a little confusing, but with practice it will become easier. Okay.